Now before we leave the inner planets for good, I want to go over a few more of the settings in this application. So we're going to hit the settings. You can also hit the Y button on your controller. So there are a bunch of options for the DK2 for how the game works. Drash loves to add options. Pretty much anytime someone's like, I kind of like it like this, he'll be like, I'll add an option. So there are options for everything. The debris field is those little rocks you see around you, so I can turn those off. Now they're gone. Now they're back. VSync, if I turn that off, we can get a look at my actual frame rate here. I'm running 220, 230. Pretty good. I'm happy with that. Anti-aliasing is locked on, which is just as well because it definitely makes everything prettier. Always show frame rate, so if you don't like the frame rate shown down there, you can turn it off. I like having it there so I can check on it in case there are any performance problems. It's not obtrusive if it just hangs out the bottom of my panel. The music you can turn off if you want to. I don't recommend it. The music is gorgeous and so fitting for the atmosphere of this game. The microphone, this is a new feature, brand new feature. You can actually pipe your microphone audio into the game. I'm not entirely sure why you'd want to. Maybe if you wanted to have like a teacher talking into it while you're going through it. I don't know. Alright, object labels. You can turn those off, so you're just looking at things. So at this point, it still displays the text down here, but you have to like recognize what things are just by how they appear. So I'm going to turn those back on. Voiceover, they're going to do a voiceover. That doesn't exist yet, and there will be subtitles for the voiceover, of course. Info text is just this thing that appears on your panel in front of you. I'm going to leave that on. I find that very instructive. Keep planets visible says that after you visit a planet, it will stick around. I like that a lot. I like to be able to look back and compare to the planets I just visited, so I'm going to keep that on. Route length. Route length is currently set to complete. It can also be compact. Compact means you just visit the, quote, most important things, like all the planets and a few other things. And you don't visit as many moons and asteroids and things like that. I like complete. I like to visit everything. Route intensity, I think this is just kind of how fast it moves you around. I'm going to stick with low, just because it's the default. I want to have the default experience. Looping mode, you can make it loop once it reaches the end and start over from the beginning automatically. Non-stop mode, you can make it so you never have to press the next button to make it go. It just automatically keeps going. And so that can be nice for like a demo booth where you want to have it non-stop and looping, so anytime someone can just put it on and be like in the middle of space looking at some random planet, depending on where it is. Okay, next, the DK2 options. These are important. So if you're running in direct mode, mirror to desktop will turn on and off the mirror on your screen that shows other people what you're seeing. Camera bounds, you can actually activate this also with your left trigger. If you hit it once, it turns on this wireframe. This is a lot like in the desk demo. My camera is at the apex of that little pyramid. And as long as I'm moving my head inside this area, it will track me. If I start to get too close to the edge, it will lose tracking. And I'll get stuck like that. And obviously you don't want to go through the tour with this thing around you. So it's just for checking your setup. This one is more plausibly something you would use all the time. It's proximity mode. So if I lean to my right now, these circles appear. The circles are telling me you're getting close to your camera positional tracking boundary. This is where it ends. So I back away when I see those, and that way I don't lose tracking. I don't like to have proximity mode on either because these circles appear over my head because the top of my tracking boundary is quite close to my head because I never lift myself up in my seat. I did that on purpose. So I'm just going to turn that off. Low persistence is exactly what you think. I turn it off and the scene gets brighter, and I now have motion blur when I move my head, which is not desirable. So back on you go. Time warp. I actually have time warp turned off at the moment. Time warp just decreases latency a little bit. In this particular application, I don't personally find it makes a big difference for me because it has such a solid frame rate. It never really drops frames, and it's and the latency is already so low. That doesn't make a big difference for me. So I'm just going to save some CPU and turn that off. Positional tracking, you can turn it off altogether. You wouldn't normally want to do this, but just to see what it's like, this is what it was like on DK1. You lean from side to side or forward, and everything, you lean forward, then the panel runs away from you, so you can't get closer and read the panel, which is very annoying. You can't like look off the side of your thing. and you can't lean left and right to look around the planet in front of you. So I think positional tracking adds a lot to this experience, so I'm definitely going to leave that on. I like being able to look around Mars and look down off the edge of my seat and lean in and read this panel closer. Those are all great experiences. Body seat, so by default you have a body and you have a chair. You can turn off your body, just have a chair. If your body is distracting or doesn't match up well with your own body, or you just don't like it, you can just turn it off. And you can turn off the seat as well. Now you just have a spaceship with no chair. But I like having them on. This demo can actually be even more immersive if you just put your hands exactly where this person has their hands. I prefer to have my hands on the controller so I can control things, but if you're doing a head tracking only demo, I recommend sticking your hands right where your body's hands are. That can make it more immersive. Alright, F10, black smear correction. This just makes the scene a little bit brighter in the black areas. It adds a little bit of a green cast to it, but it's not too bad, and it eliminates the black smearing effect when you turn your head. I'm going to leave that off just for you monitor viewers. And blur when tracking is lost. This is a new feature. If I lean outside of my tracking volume now, it'll get blurry. That lets me know that I've gone outside. I don't need that. I think I can tell when I'm outside my tracking volume. And that is all of the settings. Let's go ahead and jump back in there. Get out of here, settings. Alright. Alright, Mars, I've had enough sitting around here with you. It's time to get out of the inner solar system and on to the asteroid belt, apparently. Look at all these little asteroids. Ceres! Ceres is one of the biggest asteroids. The largest asteroid and one of our 5 dwarf planets. 2.7 AU from the Sun. Dawn is en route to look at it in 2015. That's pretty soon now. It'll be cool to get a closer look at Ceres here. I can really lean around it, get a closer look at it. Look at its little surface. Isn't that cool? And seeing Jupiter behind it like that, it's all very cool. And it looks so small. It looks like, I feel like I could carry Ceres around in my arms. I would have to use both arms, but I could carry it around. Ceres is the, quote, missing planet in the large gap between Mars and Jupiter. Discovered in 1801, was considered an official planet for 50 years until it was changed to an asteroid. And it was only reclassified in 2006 as a dwarf planet. So, for 50 years back in the 19th century, this used to be a planet. It used to be Ceres, the planet between Mars and Jupiter. But it's not a planet anymore. Now it's a dwarf planet. I still think that's pretty good. I mean, Pluto's a dwarf planet, so it has good company. Usually cannot be seen by the naked eye. The chemical element cerium is named after it. Surface is probably a mix of ice and mud. Oh, you actually have water ice? That's pretty cool. Water vapor emission detected at the surface, which is characteristic of comets. You're not a comet. Why do you have comet characteristics? Whatever. Alright. Let's go ahead and continue. I'm just going to hit my X button. There we go. Where are we going now? Are we going to Jupiter? Or are we visiting another asteroid? I haven't played this far in the new demo before. I don't know what's going to happen. Oh, we're going to Jupiter. Oh my god, it's enormous. Look at this thing. I have to move my head to look all the way around it. So big. Wow. Jupiter, largest planet in solar system. Distance from Sun, 5 AU. Volume, 1,321 Earths. And it has at least 67 moons. We literally do not even know if we have found all of Jupiter's moons. That's how many moons it has. That is ridiculous. The Great Red Spot, GRS, is a storm that is 1 to 3 times larger than Earth and has existed for over 300 years. That is a big, big storm. I'm glad we don't have any storms that big on Earth because they would completely destroy the planet. And it seems to be shrinking and disappearing, and Juno is going to show up in 2016 to take a closer look at Jupiter. Jupiter is mostly made of hydrogen in its various forms. Wait, hydrogen has a metallic form? Is that really true? Man, I must not know my chemistry very well. That's really interesting. And might have a small, solid, rocky core somewhere down in there. Cloud layer is 31 kilometers deep. Upper clouds are made of ammonia ice, and somewhere under that are water clouds. There's water on Jupiter. That's pretty cool. And there might even be more water on Jupiter than there is on Earth in those clouds. Also has a wide and faint ring system made of dust, not ice. I can't see it, but I guess it's here. Alright. Where are we going now? In the original version, we visited Jupiter's moons, so I assume we're going to take another look. Oh, whoa! Was that an asteroid? What even was that piece of rock? Oh, hey, Jupiter's moons! You're two of the biggest moons, Callisto and Ganymede. Callisto, most suitable place for human base near Jupiter. I'm going to take your word for it. I guess it looks reasonably sized? It looks about the size of Mars, I guess. Well, smaller than Mars, but reasonably sized. Ganymede, at 0.07 Earth's volume, largest moon in the solar system and larger than Mercury. Jupiter is so big it has a moon that is larger than a planet. It is larger than Mercury. That is so big. You're a big moon, and you're a big planet. You're a big planet. Callisto, third largest moon in the solar system. You're pretty big too. Surface is extremely old, dotted with frost deposits. That must be what these things are. They're frost deposits. Has an exosphere made of carbon dioxide and oxygen. Not unlike, I guess a mixture of Mercury and Mars. Like Earth's moon, one side always faces Jupiter. Oh, so it's tidally locked with Jupiter. That's pretty cool. I like you, Callisto. You're a cool moon. What about our other moon friend? Ganymede, the only moon known to have its own magnetic field. I don't think all the planets even have magnetic fields. What makes you think you're so special? You're like a moon that is practically a planet. What is up with you, Ganymede? Twice the mass of Earth's moon. You're bigger than our moon. Has an exosphere made of oxygen. Possibly has layers of underground liquid saltwater oceans? Really? This moon is starting to sound like a place that things could actually live on. That is pretty intense. Because it's got that magnetic field to get rid of the UV rays from the sun, and it's got the water, and it's got oxygen. Yeah, that's pretty interesting. Okay, I'm gonna keep going. I'll use my X button. Where are we going now? Oh, more Jupiter moons. Hey guys, Io and Europa. Whoa, we're getting super close to Io here. We almost hit it. So these moons are all similar in size. Like Ganymede's big, but Europa and Callisto and Io, they're all still pretty big. They are all relatively large moons. They're all bigger than our moon. They are big moons. Okay, Io. Most geologically active object in solar system has 400 active volcanoes on that little surface? You need to calm down, Io. Europa. Smooth surface of water ice. Possible ocean under surface. Attempt no landing there. Not quite sure what that's a reference to. You astronomers can inform me. But yeah, having a surface that's composed of water ice and being smooth, it's like the solar system's biggest ice skating rink. That is pretty cool. You can see those giant gashes in it. Europa. Jupiter's giant size and gravity puts stress on Europa's surface, smoothing it out and opening up cracks and fissures. That's what those are. Water plume detected just once in December 2012 from fissures near the South Pole. So water came out of there. That's pretty cool. Europa's fissures ejected water at a rate 35 times that of Enceladus's cryovolcanoes. Is that another moon? I don't know. But that's a lot of water you got there, Europa. Okay, tell me more about Io. Io has an exosphere made of sulfur dioxide. That doesn't sound pleasant. White areas are sulfur dioxide frost. Yellow regions are mostly sulfur. That explains why it's yellow. It's basically like a giant rotten egg. And that's frost, sulfur dioxide. Pretty cool. Also, I think I was wrong about the silhouettes. I think this moon actually has a rugged silhouette. So that's pretty cool. Due to its proximity to Jupiter, Io receives massive amounts of radiation and is heavily affected by tidal forces from Jupiter's giant size and gravity. Okay, maybe it's not such a great place to live, what with all the sulfur and the radiation and other unpleasantness. That's fine. Let's leave Jupiter's moons behind. Oh my god, look at how big this planet is! I feel like this planet feels like it's like as big as a large building. As tall and as wide as a large, like, 5-story building. That's how big it feels. Oh, hey Saturn. Are we checking out your rings? Are we going into your rings? So Saturn, as you can see, is smaller than Jupiter, but still pretty damn big. Distance from Sun, 9.5 AU. Volume, 764 Earths. That's still a lot of Earths. 62 known moons. We still can't count its moons. It has quite a lot. Jupiter had at least 64. You have at least 62. You're making us look bad with our only one moon. Rings are 10 meters to 1 kilometer thick, made of water ice. And there's a hexagonal storm at the North Pole. Oh, I want to see. Can we go to the North Pole? Oh, I can't see it. That's fine. Can I check out the rings at least? So the rings are made of water ice, so that's pretty cool. I wonder how much water is in these rings in total, because they're so huge. I wonder if it would be like enough water to fill the oceans. Or if it's just like all spread out and not actually that much. Let's learn a little bit more about Saturn. Saturn may be smaller than Jupiter, but its cloud layer is more than 6 times as thick. 200 kilometers. It has cloud bands like Jupiter, but the bands are much fainter. I can see that. The interior is very hot and is composed mainly of hydrogen and helium in gas, liquid, and metallic states. That makes sense. I mean, Venus was hot. It had a very thick gaseous atmosphere. And Saturn's is even thicker, so it makes sense it would be so hot. Even being this far away from the sun, we are getting farther and farther from the sun. Occasionally has storms that stretch all the way around the planet? I would be seriously worried if Earth ever had like a hurricane that's literally stretched all the way around the circumference of the planet. Saturn has the only hot polar vortices in the solar system at both poles, and it is orbited by Cassini, a joint mission from ESA, NASA, and ASI. ASI? I don't know. But yeah, so we've got a spacecraft checking it out. Plenty more to learn about Saturn. I mean, we haven't even found all its moons yet. Alright, let's continue. Look at these rings. Oh, wow. I wanted to, like, jump out of my spacecraft and go down and walk around on those rings, even though I know they're actually made out of water ice, just like the clouds. Oh, hi, Pan. Didn't see you there. Pan is super, super tiny. Pan, 32 kilometers wide and walnut-shaped. Like, even when I zoom in on it, it's still so tiny. Like, Deimos was tiny, Pan is also very... I'm not sure which of them is smaller. I think Deimos is smaller, but Pan is still small. 32 kilometers wide, walnut-shaped. It's not even round, because it's not even big enough to, like, become a round moon. And it orbits inside the Encke gap, which is this gap in the rings, 325 kilometers wide. Pan's gravity sends ripples hundreds of kilometers into the ring. Walnut-shaped due to accumulation of loose material in the Encke gap, not massive enough to become spherical. Pan is known as a shepherd moon because it helps keep other ring material in place. There exists a thin ringlet in the same orbit as Pan, except for the area around the moon itself. I see. Well, Pan is cleaning up the rings. This ring system is the first and most expansive one ever discovered. Rings appear solid from far away, but it actually contains an uncountable number of small pieces of ice and rock, each in their own orbit around Saturn. So this is made out of lots of little chunks of ice and rock, all going around Saturn. Some people have said that someday if we keep like throwing junk into space, we're gonna end up with our own rings made out of like screws and bolts and pieces of spacecraft and stuff like that. It might look something like this. There's a lot of space in the rings. If all ring material was compressed into a single round body, it would only be 100 kilometers across. That's like a small moon sized. That is pretty tiny. It's all spread out. Alright, let's continue. I think we're going to be visiting them. Hey, Saturn's moons. Oh, we're visiting one of your little moons. Oh wait, you're not a moon. What are you? Known as the largest centaur.